Hello, welcome to an episode of Beam There, Done That. Again, I'm with my co-host Francesco Cesarini.
Hi there, Francesco Cesarini, also co-host, as Alan said. Breaking news and exciting times. For the first time in over a decade, Erlang has a new native data type. And today on the Beam There Done That podcast, we have one of the people who helped build it. Not only did he help build this new data type, he helped build most of the runtime systems which runs on it and on which this native data type lives. We've got Björn Gustavsson, also known as the B in Beam. So welcome to the show, Björn. I think you and
Thank
I
you.
first met in 1996, if I remember. I think we were working on the ANX project together with Mike Williams. We were bringing broadband to the masses. Did I get the year
Yes,
right?
yes,
It
yes.
was a
It was.
while
I
ago,
worked
yeah.
there for about 6 months, and then I went to the UTP team and have
Yeah,
stayed there since.
I remember that you didn't hang around that project long. You moved on. Yeah, you did move on very quickly to the OTP team. Why don't you introduce yourself to the listeners, focusing on your career path, which I assume landed you your dream job because 30 years on, you're still there.
I'm self-taught. I didn't really go to any university, so I first learned to program on a TF-59 program calculator, then move on to computer in school. So ABC 8 was a Swedish computer. And then I got interested in digging deep. So I started to look at how is a basic interpreter implemented. So there was a book, someone has disassembled the basic interpreter, written some comments. But it was written in Z80 assembly language. So I studied that book, and so I suppose I've been interested in interpreters and compilers for a long time. Another thing I did with the interpreters, it was the text adventure. There was a company called Infocom that did very good text adventure, and they had a virtual machine called the Z machine. And I disassembled it myself and studied to understand how it worked. Actually, I didn't have access to internet at that time. So when I got internet access, then I saw that has already been done, or reverse engineering. But I learned a lot from doing it anyway.
Bjorn, before we get into the native records, right? You have to admit that when we're doing this podcast, we don't have. I think you're the only one so far that's actually kind of deeply involved into the internals of the beam itself. After all, you're the B in the beam is what I hear. Let's kind of talk a little bit more about why you got into that. I mean, I don't think many people would join working on Erlang and then be kind of deep into the internals. So let's talk a little bit more about how you got into it and are you enjoying it and more about that if you don't mind.
Yes, it was. So I was, as I said, I was interested in the compilers, interpreters, and all that kind of low-level stuff. And I worked at Ericsson in 1996, and then I happened to meet Tony Rågvall, uh, who was involved in the Erlang system at that time was called Jam. So I happened to meet him on the bus on my way home, and I knew him from the TI-99 home computer days. We both had TI-99 home computers, and I worked a while at Texas Instruments. So we knew each other. And he said, "Oh, you should come and work with Erlang and improve Erlang and all that." So yeah, so I did. So that's how I ended up at first ANX project and then the UTP team.
Well, I mean, the hottest news, which you helped to kind of lead on there, along with some other people, is about native records, right? I mean, we've had records within Erlang itself. Elixir basically skipped over that for some reasons. I forgot what that is, and decided to go with more structs as their kind of native type. I would like to hear more about what took so long. Why is it that we've had this record type in Erlang since I'm not even sure when. Maybe you have some kind of idea, and to now actually having an actual native type that is the first pass. And yeah, why is it take so long, and why do we even need it now after so long?
Well, I think that records worked well for a very long time. And then we had introduced maps. I suppose we might talk a little more about that later. We thought that was a good replacement for records. Then we were busy with other things. And then recently came up, but maybe we should do something about the records, do something better. Yeah, I think that's basically it.
Just to give the listeners the context from where this came from, records were not part of the original Erlang specification. They were added in the language in 1995 as part of Erlang 4.6. It was probably the most feature-rich release ever in the history of Erlang. Many of these features, came as a result of the feedback from the mobility server, which was, the first project which, made it into Erlang project, which made it into production, as well as the lobbying, I think, from Phil Wadler to really make Erlang functional. So it included records, it included list comprehensions, it included funds and higher order functions. Now, going back to record, there's a design which has been frustrating us all, for about 30 years, and it was made, to fit the constraints of the time. And if I remember correctly, every variable, at least in the jam, so Joe's abstracts machine, had a 4-bit tag for the data type. Every bit combination at that point in time was already in use because, I mean, after all, who needs more than 16 data types in their programming language? So what they did was a workaround, to let the precompiler translate record syntax into operations on tuples, as increasing that tag would have maybe been too disruptive and taken too much time at the time. So it's a workaround which lasted around 30 years. Is this what happened back then? Was that also your recollection?
Yes, I wasn't actually didn't use Allan in that release. My first version I used was OTP R1.
I was in
But yeah, I
implemented
think
computer
that
science lab, then. So yeah.
So I think, but that is correct. There were no free tag bits. No, it wasn't possible to add a 17th type. So they had to do it in that way, and it was also much easier. And I suppose it was Robert Wording that did it himself in the compiler. So there were no. He didn't have to go into the runtime system. So I suppose that was a lot easier.
That's correct. And just for the context, OTPR1 was the year after, so it was 96. So now, it was a hack basically. Now, the listeners who've been around for the Beam for a while are going to think, but didn't we get maps in 2014? Wasn't that supposed to fix that? And you know, in my view, the answer there is more interesting than you might expect. Björn, walk us through that, because around 2010, Richard O'Keefe, those of you who've not heard of him, he's a computer scientist from University of Otago, New Zealand. Very influential. He's the author of the classic Craft of Prologue book. Submitted a proposal called Abstract Patterns, which was basically a thought out records replacement. Do you recall that?
Yes, I recall that. That was interesting suggestion, but and we considered, but it was very complicated to implement, and to have it be really useful, we would have to do a coding line between modules, which was something we couldn't do in a good way. So you thought we couldn't really implement it.
You use the word complicated. I mean, I recall him presenting abstract patterns at the Erlang user conference one year. And at that very conference, Klackek, so Klaus Wiström, so the implementer of Mnesia, the person who created Erlang distribution, came up to me and said, "Oh, wasn't that a great presentation?" And and I told him I didn't understand a word of what he said, and Clacky looked at me, replied, "Oh, neither did I, but wasn't it great anyhow?" And I think everyone at the conference agreed it was a great presentation, but no one quite really understood it. You had to go back and read that paper on abstract patterns, 3 or 4 times before you really got the details. It was pitching, and but if I recall, the OTP team agreed it was one of the best record replacement proposals anyone had made. And he later on even went in and proposed frames where he referenced abstract patterns. But despite that, you went in and shipped maps instead. What happened there?
Yeah, so actually we looked at the frames suggestion, and we maps are based on frames with some changes. So frames don't need a definition before using it, just as maps. So we took that idea. Also, we took that idea of how to implement it, and we used that for small maps up to 32 words in elements in size. But we combined that with another idea. A better dictionary or associative array structure implemented with a tree structure called HAMT, or I think it's actually hash as associative array try or something like that. I suppose we could post a link in the comments. This HAMT data structure is a good way to define a dictionary or associative array. So we combine that with reach our key frame suggest and create the maps. And we did, of course, some changes to the syntax. But maps are basically a standard version of frames.
My question here, Björn, why has it taken so long? We're looking at the paper right now, and the ideas have been floated around since 2003, with the fifth draft, at least in what we have here, from 2012.
But maps are really frames, but it took us a while to realize that it didn't really solve all problems with the traditional records, or to state it in another way. For some use cases, maps are not better than traditional records. That took us a while to realize after we have implemented maps. And then we got busy with other things. So I think it's a matter of priorities. We wanted to do optimizations in the compiler, and then Lucas and John invented JIT. So we were busy with that for several years. So it was only last year we actually could start seriously work on native records.
What changes in the Beam runtime actually happened since the first implementation of record, which opened up the ability to include maps, to include native records, and other constructs?
So that problem with the tags having I've used all 6 on data type, the data types, that was actually solved in R7B quite a long time ago. I don't remember which year, but we use another tag scheme. Should I tell you about tags anymore? Tags are basically we use, yeah. So we use some bits in each word to tell which type it is, because Erlang is typed in the runtime system. We don't want to crash if you try to add an atom to an integer. The runtime system will check the tags, see the incorrect types, and will raise an exception. So we always had tags, but they were fixed to be always 4 bits early, and there were several problems with that. One problem was that we couldn't have pointers that could address 4 gigabytes of memory at the time that we ran on 32-bit computers. So that was an increasing problem because it was starting to get possible to actually have that much memory in a computer. At the beginning, it was not a problem. You didn't have that much RAM anyway. In UTP R7B, Mikael Pettersson from the Hype team, and Hype was a project at Uppsala University, high performance Erlang project. As part of that, Mikael Pettersson implemented a new staged tag scheme, and that means that tags have different sizes. So the smallest tags used for pointers had only 2 bits. So in that way, you can point to the entire address space. And one of the, so there's 3 pointer types, and then the fourth value of bits indicates that there are more tag bits. So then we have, if you have 4 tag bits, one of them is integer. I suppose one is kids, I don't really remember. But then there is one of them says that it's additional 2 tag bits. So you can have six tag bits. So Atom, for example, has 6 tag bits. And then for things that are pointers, we have a list pointer to lists, and then we have a box pointer, we call it, points of tuples, points of maps, and everything else. And then each of these objects have their own header. So a box pointer points to a header word, and the header word has its own type. So in that way, we were able to combine more types of Erlang terms.
Can we talk a little bit more about these tag bits, right? Because this is the first I've ever heard of them before, and I think people who are not really deep into the internals don't really quite understand them and why they're so important within the Beam. Can you expand a little bit more on that exactly?
Well, yes, Erlang has types in the runtime system. We must know the types. We don't do illegal operations, so we are not allowed to crash. So if you have a language such as C has types in the compiler. So if you're saying you have an int, okay, so that is probably 4 bytes, and the compiler knows that, and so there's no need to have any tag bits for C and other such language. But since the Allan compiler doesn't have types, we must have it in runtime. So it will tag each term with 2 or more bits nowadays to see what type it is.
Now I'd like to kind of go back to the history, right? Going back, you did talk about that there was things that are more important at the time. That's why maps are kind of pushed to the side, or sorry, but that's why native records are pushed to the side. But there was maps that were created, and they've been held up for some time. I mean, after all, Elixir's been using them for some time for their kind of native type, and we've had maps for some time too. Kind of coming back to it. Now it looks like with this new native record type, we're shipping something similar to what was proposed a long time ago. Was there something learned in between when maps were sent out to now native record came out that you've learned some lessons in between and said, okay, now this actually makes more sense. We should do it now, and we've kind of learned what we need and what we don't need after running things in production for some time.
Yeah, I think we learned that maps was not a perfect record replacement. That actually traditional records worked better.
Was it for speed? Was it implementation details? Why would, and I know the recommendation, if you've got a number of elements, go for maps. If you've got a fixed number of elements, go for records. But why, and that was the recommendation, but why did we go for that recommendation? Because your maps could have been perfectly interchangeable. And quoting Joe Armstrong, you add a construct, you add a data type, you need to remove a data type because simplicity was key.
It's not that easy to remove something. We can't really ever remove something. Someone is using it. But that aside, one of the problems with maps is that you can, if you spell the field wrong, it will not be noticed at compile time. So that was one of the problem. And also, it was not supported in ETS and NISIA to have maps directly at the top level. You could, of course, put a map into a record or tuple, but you could have it top level. So it couldn't really replace in that way. You can still don't do that with native records, but we are planning to fix that later.
Okay.
So that is one of the things I remember.
As a fairness check, it's been a while since I read Richard O'Keefe's paper on frames, but yeah, as a fairness check, was Richard O'Keefe right?
Right. Okay, could
Well,
you
with his,
clarify that? Right in what
I mean, he
in
came
what
up
way?
with he came up with a lot of suggestions and improvements and enhancements, back in, 15 years ago. Yeah, well, some even 20 years ago, dating back from 20 years ago. Yeah, I'm here looking at. Let me share the screen here. I'm looking at the EEP, the Erlang extension proposal from February in 2019. He came up with a lot of proposals.
Yeah, we implement here it is, the abstract patterns. Yes, I forgot. This was action and
It,
EP. Yeah.
yeah, it came
Yeah, I
as an
think that
EEP, which, yeah.
yeah. We found it too complicated to implement,
Mm.
and also that inlining across module boundaries is something we still haven't solved. Yeah, I think it could be done if we know that it would improve performance, but that is a lot of work just to implement that inlining. It's because if you inline across module boundaries and then reload one module, well, the code could be wrong. So in some way, we would have to handle that. So that's why we didn't implement that, and probably never will, I suppose.
The runtime headroom, learning what you've learned from having maps, both have been true for years. What's changed more recently that native records have become more buildable, more usable, more something that's kind of higher up on the chain to tackle?
I think it's actually mostly priorities. We had done a lot of compile optimization, had the JIT, and so no. And I think it's also that there are some that have large code bases, such as the WhatsApp team at Meta. They have a very many millions lines of code. I have no idea how much, but and many developers. And static typing is important. So Meta suggested it, or the WhatsApp team at Meta suggested, because they wanted a better static type checking. So they came to us and suggested it. And actually, a few years ago, so we have been discussing it with WhatsApp and within OTP. We finally decided now last year, okay, now we'll actually do it.
Just for the listener who hasn't tracked OTP versions, these type-based optimizations Björn is talking about shipped, if I recall correctly, in 2022. And just for the concept, the JIP compiler, shipped in 2021. So, we're talking about infrastructure which has only existed, for a few years now.
And coming back to the native records, right? What kinds of things had to be added to both the compiler and also the runtime? Because it's not just okay. Now we have it. We have a record type and end of day, right? There's got to be some things that were added in to make this happen, right? It's not just add in, because the biggest change I've seen recently is about the type. Now there's a record type when you do the I don't know what that's called again, when you declare a type within the module. So there's a lot more things that are actually under the hood that people cannot see. So can you talk a little bit about what those things under the hood that you had to implement?
In the runtime system, we had to find a new tag, and actually we did that by reshuffling some tags. So yeah, we can use a range so that some types can get a little more complicated to handle, and so we can free some tags. That is usually possible now. And John did that. So actually, John Högberg in the compiler team did the first prototype in the runtime system. So he fixed the tag. And then there is the loader, the beam loader, need to load the definition for native records. So I added that. And then we have to actually implement all the runtime functions for all native record operations. And then after that, we have to implement instructions for first the traditional beam emulator. That is usually easy to get working to get it correct. And then we can write test cases and run them. And then we've done that, we have to implement it for the JITs, and we have 2 JITs now. We have one for 886.64 and one for ARM64. So we have to implement code generation for both, for all instruction for both of those JITs.
So the 3 things, right? The runtime headroom, the lessons that you learned from implementing maps, and finally all the compiler work you just discussed. None of these things alone would have been, enough for native records for this year. So what's the one thing that's kind of tied them all together to actually make native records pushed out this year and so quickly?
Yeah, I think it's actually that we decided native records have the highest priority, and we will do it now. And it turned out to be a little bit tight, but we managed, Jan, Isabel, and some others in the team. We managed to implement all the correct features and make it correct.
Björn, the timeline on this is worth pausing on and thinking about a little bit, because you filed the Erlang extension proposal 79 in mid-January. Let me share it on the screen here. Yeah, in mid-January, and the implementation pull request was up by early February, so that was 3 weeks later, and OTP 29 shipped in mid-May with native records in it. This sounds really fast. 4 months from EEP to release, and this is for a feature we've been arguing about for over 30 years. Were you actually working on this before the EEP went public, or joking, did you delegate it
Yes.
to a coding agent?
No, I will not give you a rant about AI. But as you can see the date. You can see the date in the EP that actually
Oh,
started
actually,
working in 2024. So we
2024,
worked
that's
on
right,
it
yes.
internally. And could you show the co-authors there also, if you scroll a little bit to see
They
the
are,
authors of them?
okay, yes.
Yes, yeah. So can you show the little bit bigger the author line
Yeah,
at the
let me
top,
do that, yes.
if possible? So you can see that this was in progress from 2024 at least, and there had been internal versions at WhatsApp. They had come with this suggestion, and they have written internal version at least. And then Lucas wrote a new draft. So these are originates from WhatsApp, from Ilya Kluzhnikov and Misha Muskova, both at WhatsApp. And I edited this, updated a lot, and this was discussed in the OTB group, OTB technical board. So we had a lot of meetings discussing this and polishing this for several years before we started implementation. And then we decided in last year, okay, now it's time to get going. And I based my work on a prototype by Jon for the runtime system. Ilya Kluzhnikov implemented prototype for the compiler. So he added a struct data type because the original suggestion was to call it struct. So that was what he implemented. But based on that, we created the real version, and to tie it all together, added the missing bits that I talked about runtime system, and Isabel worked with the compiler, the shell, and dialyzer, and some other parts. And Jon also helped out with a few things in the runtime system.
The timing makes sense. Let's get into the design itself. Of all of the decisions you made in the EEP 79, there is one which I think the wider community is still thinking about, and it's the fact that the record carries its own definition with it. So the schema travels with the data. Can you walk us through that?
The idea was, okay, let me tell you about the problem with tuple records. If you have a a record created by version of code that you don't have loaded any longer, it could change, so the module is unloaded. You can't really do anything with this record. It's just a tuple. So in some cases, if you want to do a hot code update, you will have to treat record as a tuple, handle it as a tuple. So we wanted to be able to always treat it as a native record, so that it always work, even if the code that created the record had been unloaded or changed. So that was the idea about that.
When we talk about the definition being captured, where is it actually captured? What's actually inside the native record at runtime that isn't inside the tuple record?
A native record has a pointer to the definition, and the definition is just a tuple. It contains name of all fields, also contains the module name, record name, whether it is exported or not, and a few other internal fields that are useful. And usually this record definition is literal. It is in the loaded code, and it's shared by all records created from that definition, all records in the entire runtime in all Allan processes. So we don't waste memory for keeping the definition around.
Well, what does this mean for a typical developer, right? I mean, does this actually have some kind of difference to it? I mean, for me as a developer, I'm just, writing my code, but should I really care that this kind of stuff is happening? Is there some kind of difference that this brings to us?
Well, for the developer, having the record field names so long is very useful for debugging. If you print a huge record with, say, 20 fields, for example, we have done one of them in the lint module, part of the compiler. It has a record with maybe 20 or 30 fields. And when I print out that, trying to see, okay, which field is which, it's very difficult. So having the field names there is a lot of help. So actually, I plan to very soon change some of the records in the compiler to use native records, just to help with debugging.
To kind of put together everything you're saying. So if I'm understanding this right, a record is closer to a self-describing data type or a self-describing message than a struct, because it carries its own schema. Is that a fair understanding of what you're telling us?
Yes, it is. Yeah.
Cool. So Björn, this design has consequences. So let's walk through two specific use cases. So first and foremost, hot code loading. The Erlang documentation has a whole section on adding and removing fields across module versions. Can you walk us through what it looks like and why it's different from what was possible before?
I think it's more about it's more convenient. You still have to pick all the fields from the old record you want to keep, and then you will have to create a new native record and put them in along with values for any new fields. You still have to do that, but you don't have to go drop down to a tuple level and handle a tuple record as a tuple. So it's a little bit more convenient. And it's possible we might add some helpers to do that more easily for just adding a field that will basically copy all of it. And then now there is a reflection API, which means you can, it's the records module. With it, you can retrieve the name of all fields and all values and so on. You don't have to know the type. We don't really recommend using in production, not yet anyway. It's more for tools. But we might add some way to do it easier to add a field or remove a field with less effort.
Now, with this new record type, I mean, because we've been using records for Erlang for so long, will there be an automatic way to transition? Can we run some kind of command to transition those into the new record type? Or will they get converted automatically by the runtime? Or do I need to actually completely rewrite how I actually declared that record to begin with so I can get some of these benefits?
There will not be an automated translation, and the runtime will not automatically translate, and that is not possible because that would make native record worse type and have some performance drawbacks. So we didn't want to do that. So we decided to limit backward compatibility or easy migration. We wanted to make native records the best type possible, with the best performance possible. So going forward, you will have the best data type to use. To migrate, you will have to change the record definition. This is a little bit hard to describe by talking, but in principle, you will add an hash mark character and we'll remove a comma from the definition. And then it will be known to be a native record. Francesco, I suppose maybe you can show an example from the documentation at this point, maybe. So here is an example from the reference manual. We start the native record definition with the hash mark, and then followed by the name, and then we follow the name of the fields within curly brackets, and we also allow keywords as recognized. We didn't allow that earlier, so you can use div, which is the division operator. You can also start with a capital letter, and for other items you will have to quote them. This is a little bit unfortunate that it didn't show a normal record. If it's just an atom, you don't have to quote it, of course.
Of course, yeah. That's normal, yeah. Okay, if we move on to the second consequence, so we start looking at distributed Erlang, a record sent across a node boundary, what's different now? We were brought up with saying, message passing between processes, it's completely seamless if the processes are running in the same VM or in different VM and communicating with distributed Erlang. The only difference in the semantics is that the connection between the nodes can go down. What happens now when a native record is sent across a node boundary? What's different?
Well, if you don't have the code loaded as the other node, it will work anyway because you have that capture definition. It is included in the record itself, so you can actually match on it without having the correct definition. And if you have the code loaded, in that case, it will work, of course.
I assume that required a lot of thinking and tweaking to the whole design. Is that correct? I know how the OTP team works. I've been part of a lot of those brainstorming sessions, and the big challenge you have is make sure you don't break backwards compatibility, but also that you don't make it harder at a later date to go in and introduce new features. Did that happen when you started adding these record definitions which get sent across node boundaries?
Okay, I'm not sure about node boundaries. I think we had that thought out, but there were definitely things that we didn't think of before we started implementing it, and realized there are some edge cases that are not specified that well in the EP. So then we added that, discussed that in the OTB and so on. So we added more details to the EP as we went along with the implementation.
I'd also like to kind of talk about another piece that hasn't been brought up yet, or at least I didn't hear it, which is that you actually have to export the record, right? So what was the design decision process where you need to explicitly export the record?
Yes, you have to export it if you want to use it from other modules. And that was one idea. We wanted to have namespaces so that we could actually have several records with the same name but different that would work. The namespace to the module. For example, if you have a vec record is a vector, maybe we can run a 2D version, one 3D version. That will work because they are associated with their own module. So that's why we made export to share. But we wanted to be able to not share a record that should be purely internal to a module. That's also a thing. If you're a large code base with a lot of developers, you don't want someone to abuse your internal state. So that will keep the other developers honest about that.
Okay, great. So now we've covered the why and what makes actually this design difference. Let's get practical. We're working on Elixir or Erlang. There's a working Elixir or Erlang developer, even a Gleam developer listening to this, who's now wondering, when should I actually reach out for native records? When should I stick to tuple records, or when I should use maps? Can you walk us through how a developer should reason and think and so that we can help them make their design choices?
I think it can be a good idea to try it out in new code in UTP-29, see how it works for you. And we are very grateful for any feedback, things that doesn't work. So I think that is good idea. But if you're busy and you have a huge code base, you can safely continue to use the old records for now. We don't plan to remove them anyway. So that depends on what you're doing, but I think it can be worth trying out. And also for debugging, as I say earlier, it's very convenient to printing out the huge records. It just that much easier to read, having the field names there along the values.
Coming to the other Beam languages, right? As I think a lot of the people listening to our podcast are probably going to be Elixir developers or even maybe working on Gleam. How has this integration on those other languages been? Because this is kind of a cutting edge data type. I mean, and it to me, I mean, I don't recall hearing about it myself. I mean, the EAP just came out supposedly, in back in January, or at least it kind of started coming up to the headlines, and now it's shipped in 29. I mean, as an Elixir developer, can I actually start using it yet, or is this really up to the language maintainers themselves to figure out how we can actually turn these in? Because I'm also thinking, like, if I, as an Elixir developer myself, if I bring in a Erlang library that's actually using native record type, I'm curious about what my experience would be like, and I'm not sure if you have any thoughts on this or have any ideas.
I think you will have to wait for language maintainers to include support for native records. No, I think you can only pass the native records through Elixir code. You can't really inspect it in any way. I'm not sure whether they will add some support earlier to just be able to recognize a native record, or whether they will wait until UTP-29 is mandatory. But I hope that they will do some good solutions to be able to use native records in Elixir. I hope that they can migrate to using native record as a basis of structs. That would be very nice. I suppose
So,
Gleam is probably easier to do it. Yes.
so I know Jose Valin got asked at ElixirConf EU in Malaga, how native records would affect or impact Elixir, and his response, the last month was, "We don't know yet. I'm still thinking about it." So, so yeah, he doesn't have a response yet. I think it's a wait and see. Let him go in, play around, understand it better. On the flip side, Björn, when does a developer specifically not reach for a native record? When is a tuple record or a map still the right tool for the job?
For now, you can't put a native record in an ETS table at the top level. You could put the native record inside a tuple, but that's not that interesting. So that also goes for Mnesia. So if you're using Mnesia, you can't really use native record. And also the list key finding similar functions to find things in records or tuples and traditional records don't work with native records. We might come up with some other way to do it, but we don't plan to expand those functions to recognize native records.
I'm understanding there will be no support for ETS amnesia in the future. What are, yeah, is I'm understanding you correctly?
We are planning to add
So
support for
you're
ETS and
planning
NISA in
to
the
add support.
future.
Okay. Oh, okay. All right.
Yeah, yeah, yeah.
I was going to ask if there were any features which don't allow it. So that's good to understand. Thank you.
I mean, this is marked as experimental in 29. I believe you said that you're going to make some changes with 30. Is there going to be anything incompatible, or is it just going to be additions between 29 and 30? In case I decide to start to play with the native record type that I should be aware of.
When introducing something new, we usually try to guard ourselves about, but that we might have to do incompatible changes. So, but we will try to avoid incompatible changes. We will only do it if absolutely necessary. If there find some serious limitation or bug that we can't work around in some other way. So I think it's likely the syntax will remain as it is. This reflection API in the records module, it's more likely that it could be changed there, but that model is not really meant for production code. It's meant for tools, for example, to printing native records in a custom way, for example. So we don't expect that to be that widely used. There could be changes there. But mostly we will try to do extensions, and we are planning to working on the performance. We want to have performance as good as traditional tuple records. For locally used native records, I think we could make it as fast as tuple records. For exported records, I think that traditional records can be a little bit faster, but only slightly faster. It's probably not a real problem in a real application. But I'm just saying that could be a very, very slight performance loss. Probably not noticeable.
For the listener thinking about timing, the way to think about it is, explore in OTP 29, commit in OTP 30. Is that the right cadence?
Yeah, I think that is a good idea. Yeah.
Yeah, yeah. And again, for all the listeners out there, when we used to work on Ericsson projects, it was 2 to 3 years in the making, before we were able to ship, unlike, quick iterations. And I think a lot of that is still in the DNA of what gets released from Ericsson. It has to be backwards compatible. It has to be stable. Going out with something permanent and not without experimental tag, and then changing it later causes major issues, as the code base usually consists of millions of lines of code. So Björn, thinking of people with millions of lines of code, one last practical questions. There are teams listening, with hundreds and thousands of tuple records across their code base. Do they eventually have to migrate?
No, even never plan to deprecate or remove. It's simply too much code out there, and so we can't expect them to update. And in some cases it could be tricky. For example, hot code upgrade or some other thing. There could be some scenarios where it's tricky.
For one last kind of wrap up, right? As this feature stabilizes, should it be something where it's, I should get familiar with it right now, keep doing what I'm doing, keep with the old record type, and then when I want to try something, when I want to build something new, I should probably take a look at the new native record type and reach for it rather than kind of going back to the old tuple method. Is that safe to say?
Yeah, I think so. Yeah, but if you're writing Elixir, you will have to wait a few releases, I think.
We couldn't use the design, the practical questions of what to do about it. So Björn, for the listener who remembers one thing from this conversation, or even better, what maybe the coolest thing you think about this is, what is it? What should it be?
I think it's a difficult question, but I'll mention my favorite thing, and that is printing native records. You get the field name, so you get the module belongs to the record. You get in much cleaner way. So that is my favorite thing, and I think it could be interesting for many others as well.
So that's the heart of it. So, and I think to allow it, it's the fact that the schema travels with the data. And yeah, it's thinking of it's the OTP team which has been working towards this for 30 years with the conversion of the runtime, lessons learned from maps, from static records, compiler infrastructure, and all of this which is finally made it possible. And yeah, native records aren't a syntax fix, and I think it's a foundational change in how the Beam VM thinks around structured data. Is that a fair way of wrapping up the conversation we've had?
Oh, yes, absolutely.
And of course, Bjorn, we're glad to have you on. You're doing a lot of interesting work behind the scenes that maybe people, they take for granted or not really following all the details, as opposed to say, WhatsApp and some of these other kind of companies that are really deeply invested in the VM itself. How can we best follow what you're working on and what others are working on for the Beam, so that way we can kind of keep ahead of this work, right? I mean, we were thinking that maybe it's January that you work on the EAT, but actually it started back in 2024. It's a bit shocking to hear it's been so long, and now that you're finally reaping of what's been sown for many years. So how can we kind of follow what you're working on, what the team is working on?
Yes, there's several places. We have a blog at the Erlang.org site. We blog posts. I've written blog posts, and other members of UTP team has written blog posts. So at least every year we have a news post about what's new in the release, and we publish one. We have published one for UTP 29. But there are all the blogs that explains about the compiler and the JIT and optimization done, and you can also learn from how to make your code faster, more efficient by reading these blog posts. For example, adding additional type tests can make your code faster because the JIT can generate better code. And then we have, I am at the Erlang forums. You can ask questions there, and then at GitHub you can see followers there, see pull requests and then what's happened. We have the EPs, the coming new. Also at GitHub there is a repository for EPs. So I think that's all. So I'm sometimes in the Elixir forum as well.
Well, another interesting thing that's actually going to be happening in the future, right? We wanted to get you on to talk about native records because that's kind of breaking news, and actually it's breaking changes to actually some of the libraries I have, because people are actually using the record type in their type defs. So actually that's been something I've been helping to kind of fix in a couple of libraries. And what I wanted to say is that you're coming back for at least another 2 episodes from what I could see. One is to talk about the Beam and the history of the Beam, and the other one is to talk about the JIT. So this is something that we want to kind of give a sneak peek to the listeners at home about, is that we're going to catch more of you.
There's another one on top of that, which I'm preparing for the Beam episode now, and in the history of the Beam episode, and I really want an episode on the history of all of the Erlang VMs. So I think that's one which kind of came up. Looking at the Jam, looking at the V, how did Turbo Erlang become the Beam? Looking on the Ling VM, the Erlang on Zen, the Atom VM. So yeah, it's the Beam is not the only VM out there, and it's always about using the right tool for the job.
Will that be a multiple episodes, or will there be one episode with multiple guests?
It has to be. It
Sorry.
has to be multiple episodes with multiple guests. Yes.
Yeah.
Absolutely, absolutely. But that would be super cool.
I'm interested.
Yeah, that's great.
So.
Yeah, but yeah, thank you so much for being on the show, Björn, and really looking forward to having you on again. It's this was really, really insightful. And what I personally really love about the show is that we get to sit with people who build the things the rest of us run our businesses on, or used to run our business on. And yeah, today we've got the person who's been maintaining the Beam since the year, since the Beam was kind of created and started being used in production, and telling us about the design decisions which have made native records possible. So that's what the Beam There Done That podcast is all about. Hit subscribe, and hope to see you soon again next week. Thank you for listening. And just for the record, this episode was recorded on May 19th, 2026.